Don't forget to subscribe and ring that bell.
Welcome this brisk, wonderful November morning. And we are going to warm up and get a little toasty by doing some calculus. Okay? We are going to continue the 2012 practice AP Calculus AB exam that College Board put out 10 years ago. We are going to do free response question number 4. Now. We don't get to use a calculator, but it's okay because on these problems where there's no calculator, the algebra involved is usually much easier. It's just the setup of the problem. So buckle in, be prepared. We might hit a little turbulence patch here and there. It's a pilot reference, kids. It's a plane. Planes experience turbulence. Hey, like the video and subscribe, okay? Let's get started. Number 4, the function f is defined by f of x equals the square root of 25 minus x squared for the interval when x is between -5 and 5 inclusive. Basic problem for 4a, find f prime of x. We just need the derivative. I always tell my students, and this should come as no surprise to you, when we're working with derivatives and integrals, it's better if we have exponents. So I'm going to take the square root of 25 minus x squared and convert that and say it's 25 minus x squared to the 1/2 power, okay? Because if you don't know, you better know square roots, okay, it's the same thing as 1/2. I like to say, here's a 2, here's a 1. I say the top, down, bottom, out. Okay, top, down, bottom, out. So that way I can have any 3/4. Okay, again, the top, down, slides down, the bottom, out. Top, down, bottom, out. That's the way I do it. But square roots are 1/2, cube roots are 1/3, etc. You should know that. Now we have an expression that we're ready to take the derivative of. All right, this is going to be power rule and chain rule. First thing is my exponent's going to come down up front. So we got 1/2. The inside stays the same. Okay, 25 minus x squared. And now I got to subtract 1 from a 1/2. If I have a 1/2 and I subtract 1, which is the same thing as 2/2, I get -1/2. And I need to multiply this times the derivative of the inside. Okay, the derivative of that inside is -2x. Okay, so let's clean this up a little bit. Let's clean this up. Well, first of all, I have my 1/2 here. Okay, let's make all these fractions just for the sake of multiplying. We have 1/2 times 25 minus x squared to the -1/2. That would be over 1 times -2x over 1. Some of you need to see this to watch it unfold, okay? The first thing I'm going to do is I'm going to say, well, this 2 cancels with this 2. And if I have a negative exponent, I want to make that positive by flipping it, okay? So in the bottom of my fraction, I'm going to have 25 minus x squared to the positive 1/2. All right? And what's left in the top? Well, it's just 1 times -x, which is -x. That is a fantastic answer, right? Or if you want, you can convert your numerator back to a radical. What do I mean? Remember, anything to the 1/2 is like the square root of something. So if I want, I can make this -x over the square root of 25 minus x squared. Okay, if this is short answer, which it is, this is completely acceptable. But if it were multiple choice, they would tend to write it like this. Okay, either one of those is great. It's a good way to start and get our mathematical juices flowing, so to speak. B says, write an equation for the line tangent to the graph of f at x equals -3. Whenever you see equation of a line or a line tangent, you know you need this formula right here. Okay? I don't use y equals mx plus b. I use not slope intercept. I use point slope formula of a line. Okay? So I am always going to need my y and my x in this equation. Okay? These will stay here. What I need to find are three things. I need a coordinate, which is going to be an x and y here. And then I need a slope. Okay? Slope, as you know, is the same thing as derivative. Okay? So I basically need my x1 and my y1. And I need, that's a comma, not a 1. And then I need my slope, which is the same thing as the derivative, right? Right. Okay, well, they give me x here, -3. So I can say minus a -3. Whenever we subtract a negative, it's like a super positive, kids. It's like a super positive. It is x plus 3. All right, so now let's start with the y coordinate. Okay, how do we figure out this bad boy? We always go to the original equation. Whenever we have a coordinate, when we have one of the two coordinates, the x or the y, we always go back to the original equation to get the other. The original equation is this bad boy right here. Okay? So what I need to do, if f of x equals a square root of 25 minus x squared, okay? And there, struggling on how to say this. If x is -3, here, remember, this is always a coordinate. All I'm going to do is throw -3 in here. 25 minus -3 squared. Please, for the love of the Lord, please use parentheses for any time you input something. So we got 25 minus, this is 9. That's 16. The square root of 16 is 4. All right, so now it's y minus 4. All right, not bad. Now the last thing we need to do is find our slope. Slope is the same thing as derivative. We just found the derivative. Right here. This is the derivative, which means that's going to help us find our slope. Okay, at -3, right? So let's go back here, and we are going to say my slope is -x over the square root of 25 minus x squared. I want this at an x value of -3. All right, so we got -3 all over the square root of 25 minus -3 squared. We already did the bottom. Okay, in case you didn't know, this bottom is what we did right here. The bottom should be 4. The top, well, when I subtract a negative, that's a super plus again, 3. That's my slope. There you go. It doesn't say make it y equals. I mean, if you wanted to, you could add 4 to both sides. Okay? If you wanted to, I mean, some people get really weird about that. They say, oh, I don't want y equals. I mean, if you want, add 4 to both sides. Okay? You can say y equals 3/4 times x plus 3 plus 4. I mean, you could do this. I don't know why you would. This is an equation of a line right there. 4a done, 4b done. Let's keep on rolling. 4c reads, let g be the function defined by g of x equals, all right, and this is a piecewise function, g of x equals f of x for any x value in the interval from -5 to -3 inclusive. Okay? And then g of x will equal x plus 7 whenever x is greater than -3 or less than or equal to 5, okay? Is g continuous at x equals -3? Use the definition of continuity to explain your answer. So we're going to have to show some work. We want to show some work. And we're going to have to use some words to explain this answer, okay? Now, we cannot just use a graph because it says use a definition of continuity. I mean, maybe you can try and finagle trying to use a graph, but the definition of continuity states that a function is continuous, okay? So it is continuous if the limit as x approaches a value, in this case it's -3, of my function is actually equal to the point of the function at that x value, okay? So we're going to do this right here. We're going to see if these things are equal. And we are going to start with this side right here, the limit. Now, in order for a limit to exist, okay, the limit as I approach this value from the left has to equal the limit as I approach that same value, -3, from the right. Okay, so let's first establish in our piecewise function which is the left of -3 and which is the right of -3. Okay, these numbers right here from -3 to -5 are smaller, therefore are to the left. Right? And these numbers here from -3 to +5 are bigger, so this is to the right. So when I use my limit, the left limit, or approaching -3 from the left, is just going to use f of x. Right? And when I approach -3 from the right, I'm going to use x plus 7. So let's go with this, all right? Now, f of x, in case you didn't know, f of x was given to us in the beginning as a square root of 25 minus x squared. 25 minus x squared, the square root. We just did this work. We did this work right here twice. Here, x is -3. It's still -3. So I'll just say the square root of 25 minus -3 squared equals 4. Okay? Is that equal to, now I got to use the equation for the right, x plus 7. Well, -3 plus 7, because again, I'm putting in -3, that does equal 4. Okay? So now I could take this right here and say, that is 4. Does it equal the y-coordinate when your x is -3? All right, well, okay, let's do this. G of -3, it is no longer a limit. If it is exactly equal to -3, which one of these formulas or equations am I using in the piecewise function? This is not equal. This right here is equal because that line underneath the less than symbol. The one on the bottom does not have the line underneath it. So I've got to use this when it's actually equal to -3. The x is equal to -3. So again, square root of 25 minus -3 squared. We've done this so many times, it's 4. Guess what? The limit equals the coordinate, or the point. So it is continuous. So here's the definition of continuity, and we're going to explain this now. First of all, let's answer the question, is it continuous? We'll go with this like kind of bright green. Yes. G of x is continuous at x equals -3. Since the limit as x approaches -3 is equal to g of -3 they are both 4. I mean, that's it. And again, every time I do an explanation, it can be written one of a million different ways. But you want to be specific. I always say that. And what do I mean by be specific? First of all, yeah, that'd be black. Answer the question. It is continuous. Where? At -3, because that's where they were having us check. How come? Because the limit, as it goes to -3, is equal to g of -3. They're both 4. Okay, it's specific. All right, be specific, and you don't have to be lengthy if you're specific in your explanations. All right, that's it. 4D, we're done after this problem. This was a quicker one. I guarantee you what, problem 5 and 6 are going to be a little bit longer. Okay, so let's buckle down. Let's do this integration. I'm liking it. D says to find the value of the integral from 0 to 5 of x times the square root of 25 minus x squared dx. All right, that screams to me U substitution. How come? How do I know it's U substitution? I'm actually going over this with my pre-calculus class. Actually, no, my calculus class. Because there's an expression, x squared minus 25. Forget about the square root, x squared minus 25, where the derivative is 2x. So the variable portion of the derivative is also there. Let me say that again. We have an expression, 25 minus x squared, in my integrand here. And the variable portion of that derivative, 2x, the x, is also there. And that is the guideline for figuring out what you should make your u and what you should make your du. Now, a lot of people say, well, how come I can't just say, well, why can't u be 2x squared and du be 2x dx? We're going to get rid of this 2. So we're going to end up having x dx. Because again, x dx. Anytime you have a constant, bring that along, because the derivative of a constant goes away. That makes life so much easier. Okay? Whenever you have a constant, include that in your expression. So let's do this from scratch. Here. Let's end with something that pops a little bit. Let's go a little more. Let's go more. Let's go define a color. How about something a little lavenderish? Oh, that's pretty. So I'm going to make u 25 minus x squared. That means the derivative of that is just negative 2x dx. All right? Now, I only have an x and a dx to substitute in for. So I want to keep my x and my dx, which means I'm going to multiply both sides by a -1/2, because this -2 and -1/2 will cancel. What I do to one side, I have to do to the other. So let's start doing our substitutions right now. Okay? I've got an integral. In for x dx is going to be -1/2 du. My constant I put on the outside, and here's my du. Now, what goes in for this here is u. So it's a square root of u. All right, I'm going to integrate that. But don't forget the biggest part of u substitution. My bounds have to also be converted. Right now, these things are x equals 5, x equals 0. I want u values up and down here. And how do I do that? I have x's, I end up with u's right there. So when x is 5, I'm going to substitute a 5 in for this x. So it's 25 minus 5 squared. That's 25 minus 25, that's 0. My new upper bound is 0. My lower bound has an x value of 0. So it's 25 minus 0 squared, which is 25 minus 0. That gives me 25. That's my lower bound. All right? And what I would do to make things easier is just like we did in a previous problem, I think it was the derivative. I remember saying when we work with derivatives or integrals, we should always work with exponents. So I'm going to make this exponent a 1/2 power. So when I rewrite this, I've got negative 1/2 on the outside. The integral, you know what? I'm going to do two things in one step, if you don't mind. Notice that the upper bound is smaller than the lower bound. I can flip those. I can put my 25 up here and my 0 down here. I'll call that u to the 1/2 du. However, the rule says if I flip my bounds, I have to negate everything. What happens on the outside? I'm negating a negative. Turns to a super, super positive. So now I'm multiplying by 1/2. All right? Let's integrate this. We're ready to go. Let's go. So many colors to pick from. I'm just struggling here. Okay. I'm going to add 1 to my exponent. That becomes u to the 3/2. Okay? I got to divide by 3/2. Dividing by 3/2 is the same thing as multiplying by the reciprocal 2/3. And I want that from 25 to 0. And oh, by the way, don't forget, whatever value this is, we still got to multiply it by 1/2. All right, well, 1/2 times. I put the upper bound in. It's 2/3 times 25 to the 3/2 minus, love putting zeros in. I love, love, love putting some zeros in. Because if it's a 0, this goes bye-bye, just turns to 0. Now, top down, bottom out. It's the square root of 25, which is 5, cubed. Good boy. So 5 cubed is 125. That wasn't bad. Okay, that wasn't bad at all. So this is going to be 125. So I have 1/2 times 2/3 times 125. All right, well, it's one thing I know, these 2's are going to cancel. And when everything's all said and done, if I did everything right, I just end up with my 125 over 3. And that's the answer. That's the answer. Question 4 was not difficult at all, and it was very basic. Find the derivative. Find the equation of a line. Check for continuity, and then integrate. Those are 4 of the basic concepts that we learn in calculus. Derivatives, equations of lines, tangent lines, continuity, and integration. Man, this was a really good question, and it was easy. The algebra was easy. Look, we're done. Okay? Follow me, ring the bell, subscribe, like the video. I'd appreciate that. And leave a comment if you want to see another test done. We are out, and I will see you probably tomorrow for free response question number 5. Bye-bye.